All right, let's get started. My name is Hyun. I am a software engineer. I've been writing Java code. It'll actually be 10 years this summer. So the first time I did Java, I was writing a reporting thing using a connection and making SQL requests in a JSP. And now here we are at Greach. I'm sorry. Here we are at Greach talking about Groovy and no more JSPs, right? And no more, we're using something like Groovy. I'm on Twitter, Spacewalker. It's just mostly stupid things that I post about. And I don't have any slides per se, but I do have like very annotated notes and source code available on my repository for today's talk. So if you want to load that up and follow along, feel free. So yeah, let's get started. So this talk we're talking about testing Ratpack applications. Just a quick poll, how many of you have heard of Ratpack before today or before this conference? Okay, that's most of you. How many have actually played around with it? Same people, okay. How many are running Ratpack applications in production today? Okay, all right, that's pretty encouraging. So if you look around the room, you can see that Ratpack is gaining adoption, and this isn't just like random people and testimonials on the internet. These are people that are sitting right next to you. And when you're writing Ratpack applications, you really don't want to just throw a bunch of code and just deploy it. You want to make sure that it's tested, right? Like, who likes writing tests? Okay, good. All right, that's a big relief. So I'm going to help you today. I'm going to show you what Ratpack does in terms of giving you the ability to test Ratpack applications, both as a black box and at the unit level. So a little bit about Ratpack. So the testing fixtures that are made available through Ratpack, they're not testing framework dependent, and they're certainly not language dependent. So Ratpack and everything that's not the Groovy stuff is written in Java 8 as a core. So you don't need to be using Groovy, but Groovy makes writing code so much more pleasant. So that's what we'll be looking at today. Obviously, you know, if you work in an enterprise company and you might be using JUnit and TestNG, which there's no problems with using that, just like there's no problems with repeatedly punching yourself in the face, right? Like, as long as you're not hurting anybody else, that's fine. You can do that to yourself. But we love Spock. Like all of the tests in the Ratpack and in our documentation, we're using Spock. So we'll be using Spock today and Groovy. So our testing fixtures in Ratpack, they're very lightweight, which means, you know, if you're unit testing, they're even more lightweight. There's not much going on, but everything that requires, you know, some kind of server interaction won't take a whole bunch of time to bring up and tear down. At the same time, like, we're really adverse to magic within the Ratpack code base. So we don't do AST transforms. We don't have annotations littered all over the place. But at the same time, you still get a real conciseness when writing Ratpack applications and when you're writing your test code as well. And all we do is make use of delegates to and closure utils to help resolve method calls within the API. But when you take a look at what you're writing, it does look like magic, but you get the help of the compiler to help you with auto-completion and things like that. It's also really great for refactoring too, right? Like, strong types help you refactor much easier. So yeah, let's get started. I'm just going to take you through the process of bootstrapping a Ratpack application to show how very little there is to it. So in our situation for Greach, we're going to make a directory called Greach. Change into it. We'll just create a simple Gradle file. So I mean, again, like, you could be using Maven. There's nothing that's going to tie you down to using one build system or the other. You could always just use Java-C and like specify your class path and try to compile everything by hand, but why would you want to do that? So I like to use this new incubating plugins feature from Gradle. It makes adding plugins like super easy. The one caveat is that these plugins have to be registered in the Gradle plugin registry, but Ratpack is, of course. So you just add a dependency on Ratpack Groovy here, and it's going to take care of setting up the Gradle plugin that allows you to do a lot of nice things. 1.2.0 is the latest stable version, and I like to use IntelliJ. So, oops. I also like to use BinTray, so that's what we're going to go with. And for the bulk of our code, we're going to be relying on a single dependency here, and that is the Groovy test module that we publish. Oh, Groovy test. So what does Groovy test do? It's a module that includes the Java 8 test module, but also has a whole bunch of nice extensions on top of that that make working with the testing framework much nicer. So, I mean, that's it. I mean, I can't create a POM XML from memory, but this is quite easy to do. So if we go ahead and create the rest of our directory structure as needed, we'll have a source main Groovy. We'll have a source Ratpack. So we're going to be using the Ratpack script approach here, and that's the default directory it looks in. And we're also going to have our testing directories. So that's it. Let's go get started. And that's it. So let's go ahead and load this in IntelliJ, and we'll take it from there. Yeah, so here we have our directory structure, and here we have our Gradle file, and it looks like if we take a look at external libraries, yeah, we've got everything that we've needed. So let's make a simple hello world Ratpack application. Oh, there's one thing if you're working with the script-based approach. If you notice here, IntelliJ is marking this Ratpack directory as a sources directory. Really needs to be marked as a resources root. I think that's just a tiny bug there. But it's important if you want to be able to run these tests. So we're just going to make a very simple application here. This is like the popular like application that fits in a tweet, so to speak. Right, and I mean that's all it takes. If you go from the command line and you just run, Gradle run, this will take care of setting everything up, and bam, like your application's good to go, and we can curl against localhost 5050, which is the default port there, and bam, there we go. Something to note about if you're using Gradle run, like as an example, if you're using Gradle run with the continuous mode, the short flag is T, the long name is continuous. If you do this, like as you make modifications to your code, like Gradle will take care of recompiling it and restarting the Ratpack server, which takes less than a second. But we're not here to focus on the cool stuff about the cool kind of like auto reloading in Ratpack. We're going to focus on testing here. Similarly, like this just works. You can right click on your Ratpack script and just run Ratpack. And there we go. We're up and running, and we can just verify once again that we're getting what we expect. So that's pretty pleasant, right? When you can put an application together in a pretty quick way and you're ready to go. So let's do our hello world for our Ratpack's application here. So because this is a Groovy conference and we love Spock, we're going to use Spock specifications here. So of course we need to extend specification. Oh wait, I forgot to add Spock. So let's just go back here. And I do believe we want to exclude Groovy all here so we don't clash. Just need to go through the cycle of recreating the project files so that everything gets put on the class path and everything's aware. Cool. Yeah, now it has something for me. There we go. Okay, so a lot of the fixtures in Ratpack implement the Java interface auto-closable, which means it implements the close method. This is because we do allocate some kind of resources that do need some kind of graceful shutdown sequence. So for the most part, in Spock, you have auto cleanup, which is great because it'll just take care of doing that for you. And in particular, our type here is application under test. So, and in our particular case, we have a groovy main Ratpack application. So when you tell it to do this, this is going to scan your class path, find that Ratpack groovy script, get it running under this application, and it's going to stand up the entire application, and you're going to be ready to go. So in this case, we just want to make sure that we're getting the response that we were expecting. I mean, you could always do your testing through curl, right? But if you want to do that, like every time you make a change, it gets to be a pretty tedious task. You want all this stuff to be automated. So application under test has something called HTTP client, which is really a test HTTP client. It's different from the HTTP client that exists in the registry when you run your Ratpack applications, in that test HTTP client is both blocking and synchronous. We're going to get into more detail on that later. But for the moment, we can just bring it up a level. Okay, so when the client makes a request, right? And there are a couple of ways to do this, but for our case, we care about just making the request, getting the response text, and just making an assertion against that. So really, that's done through getText. So we can almost just expect that the text is going to be Hello Greech 2016. And if we run this test, we should expect it to pass. And we're failing. All right, so this is what I was talking about. Script not found exception. Because we reinitialized the idea files, we need to go back and mark this directory as resources root. There we go. So when we run this, it should pass for sure. And there we go. So this is kind of like a starting point in testing your applications in Ratpack. This is a pretty black box approach, right? This is truly your functional testing. You have no say in what goes on under the hood. All you know is that you're making HTTP requests against it. There's some advantages for using this kind of approach as opposed to maybe using something like Jeb if you're only concerned with the actual messages being sent back and forth between client and server. This is a really great way to make sure that your HTTP responses are looking a certain way, and yeah, if you're not concerned with actual rendering, this is a very good way to go. And there are a lot of ways to get under the hood, and we'll get to that a bit later. So I want to go back a moment and focus on unit testing right now. So if we go back to our Ratpack application, right, we've got this handler here. But let's say we start building out our application and we start having additional handlers now that we're now putting as a part of our chain. So we can just create a handler here, and we can extend Groovy Handler. Of course, when we extend the handler, we have to make sure that we're implementing handle. So when we register this back into the main application, so we'll add an endpoint called hello, and we'll just bind this to the new hello handler. And just to make sure that everything's good, we'll run hello handler. We'll run the new Ratpack application. We'll issue a request against the hello endpoint. and we get what we expected. All right, so it may not be the case that you want to do functional testing all the time, right? Like you might want to have unit tests, which are very useful. And in this scenario, we'll go over how to do that. So we can make a specification specifically for this particular handler. And in this scenario, what we're going to do is make use of something called the Groovy request fixture. So Groovy request fixture is a mechanism that allows you to do unit testing against handlers. So there's no server that spins up. There are no like real request response cycles going on. It's going to just it's going to simulate all that, simulate just testing your handler itself. And the way you use this is you invoke handle. It's a static method. You supply the handler that you would like to test. The handler, not the specification. And if you notice, in IntelliJ, if you take a look at the list of arguments, that might be too small for you to see, but there is some kind of block of code that you need to supply after it, whether that's an action from Java 8 or a closure in Groovy. For now, we'll leave this empty. And the result of handle, of course, is a handling result. So and I like to show the types here. They help out. So we can say like when you get this request fixture to effectively execute your handler, we can ask all things and consult, like really find out about what happened in the execution of this handler. Everything's made available through this result object. So we can expect that the body text of this is going to be hello again. So when we run this test, you would think that this would pass, but it doesn't. Okay, so this is a very surprising error message. Like, our body text here is null, but we were expecting to see hello again. And if we take a look at our handler, okay, fine, we're missing an exclamation point. But really what we're looking at is, if you take a look at the hello handler here, you can see that we're using something called the render method, and this is in reference to Ratpack's rendering framework. So Ratpack has a pretty robust rendering framework. You give it some type, some kind of object, and as long as there's rendering support for that object, that renderer supporter will come in and determine how to serialize this object to send to the user. So when we're taking a look at our specification here, because we are unit testing, like, we're not testing to see that the handler actually like invoked the renderer support and actually serialized the stuff out. All we care about in this situation is that the rendered object here, which is of type string, is hello again, which is what we're expecting. So if we run this test now, it passes. So that's a little gotcha that gets people first time around using this kind of thing. If you wanted to use the body text here, which you certainly can, you will have to make a modification to your handler, and instead of using render, you really want to use the send method on the response object here. So you would say response send, and we'd send our string here. So if we run this test again, there we go, it passes. So that kind of tells you, that gives you a little insight into the like the super lightweight nature of our fixtures in this scenario. Like, you want to render a response, and because it's a unit test, like, you don't really care to check that the response is rendered the way you expect it to. This also makes it easier for making assertions. Like, if you have well-formed objects and you want to make assertions, you don't necessarily, like, let's say you're implementing a REST endpoint, you don't want to necessarily take your expectation, serialize it to JSON, and then make that comparison there, especially if you're using like different types of JSON serializers. Right, cool. Yeah, so let's get into something. Let's make this more interesting now. So in Ratpack, right, you can modify and query anything about the request or response that's coming in. And in this situation, let's enhance this hello handler to change the message here. So the context provides us access to the request object, which has access to request headers, and we can look for a specific header here. So if we have a message, we'll set it to the message. Otherwise, we'll set our greeting to hello. And what we can do here is use some string interpolation and customize our message. All right, so our old test hasn't changed, like that behavior hasn't changed. We're not setting a message header, so all right. It's a groovy string, so it's a little bit different. And it's happy again. Okay. So how do we adjust our usage of the groovy fixture in order to test that our alternative messages can be sent? That's where this closure comes back into play. So just going to go ahead and grab this. So this closure that gets passed here, it's pretty nice. It basically allows you to interact and configure your request fixture before the handler gets invoked. And so in this situation, like we can add a header, call it message, and replace hello with hola. So in this situation, we would expect to see hola again. So let's see if this is the case. Yeah, there we go. So coming into like Groovy request fixture, like it gives you access to like a whole bunch of attributes about the request that you may want to customize to test like different types of behavior. Another thing is like if you're using Ratpack, you're also probably using the registry, like you almost have to be. And in this case, like when we're testing our handlers, not only can you add things to the registry before the handler gets executed, but you can also make assertions against what was added to the registry. So in our situation, let's add another handler here. And we'll have some kind of like profile loading handler, whatever that does. Right, so in this case, we can expect like some kind of access token or secret is going to live in the context registry as a string, right? So we're expecting that this is going to have something by the time it gets here. And what we'll do is, let's say we have some kind of like profile class here with a role and a secret. We can just take the role from a response header or something like that. And if we don't have a role, we'll just assume that they are a guest. So what we're doing is we'll take some things that we already have, we'll take additional things, and we'll start to populate the context registry. So this is kind of like a pre-processing handler that you would put maybe at the start of a chain somewhere. in this situation, this handler is not expected to render or return or send a response back to the client. What we're doing is instead delegating to the next handler in the chain. So the way you do that is by invoking context.next. And there's a simple factory registry.single. We'll just add the import statement here. And we can just add our new type here. Cool. So like canonical will give us a tuple constructor, so we can just put that right in. So let's go ahead and create another unit test for this particular handler. This is getting to be pretty long. Let's just do a static import here. All right, so when we make the request here, what we can do is, again, specify our header. This time we're expecting a role. And we'll say that this person's an administrator. And we can also do something with the registry here. And it gives us a chance to add or make inspections or modifications to the registry. And in here, what we'll do is we'll add a string, and we'll call our token secret. So when you perform this action and you run your handler, what we're expecting is that the result should have a new profile object in the registry, and we'll make that assertion right now. So what did we do? We added a header with a role, and we've added a string to the registry, which this handler is expecting. So in the situation where we have both of these things, we're expecting that the handler should be delegating to the next and sending us and populating the registry with a new profile object. So let's see if that indeed is the case. Yeah, works just fine. So you can take a look at more of what Groovy request fixture can do, but this is starting to give you an idea of how Ratpack testing fixtures allow you to get into like almost every layer and feature that Ratpack makes available. It's super lightweight, super configurable, and you can pretty much do whatever you want. This is especially easier to do when you're doing unit testing, but we'll show how to achieve the same kind of things when you're doing functional testing. Yeah, so there's one more thing I want to show while doing this kind of handler thing. If you take a look at what kind of arguments this method's expecting, there's a variant here where it takes 2 blocks of code. And what it does is it's effectively expecting a chain here, an action chain, that is. So we can actually like start building up our chain and like put our handler in kind of like these fake contexts in order to see like how they would interact, right? So it's kind of like an exploratory thing in a way as well. So in this handler, we can again add the we can add the new profile, the profile loading handler, like in the beginning, and then we could have it chained to like a subsequent handler that will actually render this profile object out. So like in this situation, right, in this particular handler here, it should be the case that the profile was loaded into the registry, so we should just be able to grab it out by calling get. And we can adjust our test here instead of checking the registry, which we can also do. We can also make sure that Ratpack is actually rendering this profile object. And we can just make this assertion here. All right. So you'll actually need to use the all handler here in order for this to work. So we'll just make that modification, and this test should pass. Yep, there we go. So yeah, I mean, using Groovy request fixture, like you can go pretty far in terms of testing units of code, which kind of brings us to integration testing now. And when you want to talk about integration testing, it's more than just doing like a couple of handlers. You probably want to like start populating a registry in a particular kind of way. You probably want to start, you know, like putting chains together. And to do that, we can just add another specification here. So what is an embedded application? It's another test fixture. It is a type of application under test, which means that it'll start up as a full Ratpack server. It, by default, doesn't have any kind of base directory. And it allows you to quickly not only build parts of an application, but it gives you like a full context that allows you to test features of Ratpack in kind of like an exploratory way. So in this situation, we can use Groovy embedded app. These import statements are really annoying me right now. So we can kind of use this this factory here, like, and build just like a very simple single handler application here, and you know, like we're just rendering hello. Two things here. Since this is an application under test, like you'll want to close this at some point. But if you just want to make like a couple of assertions against like a request response cycle, there is a method called test. And test is kind of like that execute around pattern where you just provide the block of code that you'd like to use, and Ratpack will take care of shutting down the server after that closure is executed. So this is also pretty cool. If you're using Groovy embedded app, what's given to you here is a test HTTP client. So there's no need to grab that yourself. But because we're also using delegates to and closure utils, all methods that don't resolve against anything in the immediate scope will resolve against HTTP client, which means you can just write get text and say hello. We'll want to make this a power assert here. And there we go. So we actually use the Java version of this for all of our Java documentation. We use embedded apps to display how you would, and demonstrate how you'd use like almost every feature in Ratpack. Like if you go over to the documentation right now, and I mean the Java docs, you can almost figure out how to use a piece of Ratpack code. If not, we do have a lot of unit tests that are very descriptive. Yes, we are aware like the user guide is something that gets a lot of complaints, but there is a Ratpack book that's in production right now by O'Reilly, which I'll plug later on, and that's like kind of the missing user guide that people have been asking for. Groovy Embedded App also provides like, there's so many different ways to create an application here. You can actually give it, multiple handlers, you can give it a chain, you can actually give it like a full-blown server. You can just take this like default like flexible of factory method that you just provide some kind of block of code and you get access to everything that you need. But let's say you weren't kind of doing this. And you just have some kind of Groovy embedded app. You could get the test HTTP client out from here and make your assertions against using that. You just have to make sure that at the end, in your Spock lifecycle phase, you just want to make sure that you call app.close since we started up ourselves. Yeah, okay, so I think I'm running tight on time, so I'm going to fall back to my previously prepared code and go through the rest of the examples here. So when you start working with Ratpack, you don't get very far without having to write asynchronous code. And it follows that you should be able to test asynchronous code. So, so let's see how that's done. Right. So when you're working with when you're working at the boundary between Ratpack and your user code, you want to make sure that you're wrapping everything in promises and operations. A promise is just some kind of async operation that has a value. You can think of an operation as like a promise with a void type. And you can see we're just returning promises and operations here. When you try to test this and you're not using any of like the Ratpack async request async test fixtures, you're going to get that unmanaged thread exception, which is because Ratpack has its own execution model, and it's that's kind of the only place where it's opinionated, really. So we have something called exec harness. Exec harness takes care of instantiating event loop groups and thread pools and everything that it needs in order to resolve promises. So it's pretty cool. Like if you take a look at our profile service, you can see that we're returning all these things, and it's in a typical use case, you would actually have to subscribe to the promise in order to resolve the value. But in this situation, you just provide the operation that needs to be completed. It'll get wrapped as an exec result here, and you just need to use the value to extract the values out from here. So you can see here, we're just unit testing the service and adding things and removing things to it and ensuring that it's as expected. This test does pass. All the tests pass, and these are available on the GitHub repository. I do want to get into functional testing and kind of like how you would do a bit of configuration around that. So if you take a look, like, so in my fifth example, if you're following along, we have kind of a very trivial Ratpack app, but it's not dissimilar from what you would see in your own projects. So in our server configuration, we're grabbing configuration from system properties, and we're kind of using like this JSON node annotation to anything that maps to API. We're going to put it into this like API config object that we just created. It's just a pogo, right? And so what this does is, here we go. So what this does is it'll take any kind of system properties that it finds and put it onto that pogo and make that available in the registry. So when we take a look at our conf service, we can just get this thing injected to us from Ratpack and Juice. And we can just simply use this to issue requests against whatever the URL was from from the configuration. Now, when you're testing, you don't know what kind of environment you're going to be in. You don't even know if you're going to have network access. And that's true in a lot of companies. If you take a look at our test here, we do something pretty cool here. So a couple of things, like you'll need your application under test, which just represents the Groovy script. We have our client. We're making use of delegate here so that the actual test code reads really nicely. And what we're going to do is we're going to stand up a second Ratpack application that just sends a dummy response. So this is going to send a comma-separated list of like really awesome like Groovy-based conferences. And in our setup phase of the application, what we're going to do is set a system property. So we're actually going to feed this in so that when the Ratpack application starts up, it's going to get the address of our second Ratpack application that we set up. So we're using Ratpack to test our Ratpack app in a way. And because of delegates, when we take a look at the actual test code that we use here, like, come on, like that reads really cleanly. And just to show that everything's running and working, oh, we actually got a 500. Oh, right, okay, so this is again, this is so frustrating. You just need to come in here, find the Ratpack directory, and mark it as a resource root. And yeah, that's really frustrating. And once you do that, test passes, of course. There is another way to go about, there are kind of different approaches you can take, right? And that'll be very contextual. So as of Ratpack 1.2, there is something called an imposition. And imposition provides you with an opportunity at 3 different phases to come in and just override whatever you'd like. So you have server config imposition, you've got a user registry config, user registry imposition, as well as a bindings imposition. And if you just take a look at our Ratpack again, like these kind of correspond to like each of these bootstrap phase blocks that we have available here. So like if we looked at our API service, which just made a request, we can actually, here we go. We can actually use impositions here. So what we're doing here is we're creating an anonymous implementation of the class, and we're just overriding add impositions. So what we're doing is we're saying, hey, like when somebody's asking for a conf service, just like return them this dummy thing that's just always going to return Greech. So in this scenario, there's no network calls made at all. But the test is identical, and we should expect this test to pass as well. And it does. Okay. One quick last thing that I want to get to is remote control. So using impositions allows you to get into the registry, but it doesn't allow you to really interact with what's in the registry. Remote control allows you to do that while your tests are running. So let's say we have an application that looks like this, and I'm just going to preemptively mark this as a resource root. And in our application here, it's pretty simple. Like we're going to grab profiles, turn them into JSON, and we have like an endpoint for adding these things as well. And if we take a look at, let's take a look at the Gradle script, because the only change here is that you would need to add a test compile dependency for remote test. This brings in remote control, which is originally a Grails plugin. It serializes commands, sends them over to the server executes them, and returns a serialized response back to you. So this is like, you don't want to have this running in your application in production, because it means anybody can just come in and execute arbitrary code. And that's not good at all. You just want this for testing to get even more control within. So how does this work? Again, we'll create an anonymous implementation of an application under test. In this situation, we'll use the bindings imposition, which has to do with Juice and Groovy. And what we'll do is we're going to bind an instance of a handler decorator here. So this is actually responsible for instantiating an endpoint that's listening on the application. And this will accept your requests and execute them on the server. And unfortunately, we have an unfortunate naming here. So in the test package, there is also a class named remote control, but it has a different FQN. But it's pretty simple. You just instantiate it with the application under test. And in situations where, let's say, your service returns a void or something unserializable, you just want to tell it like, yeah, that's fine. I don't want you to blow up. So this does that. You can set an unserializable result strategy and just tell it, yeah, if it's unserializable, just return null. I don't really care. So in this situation, instead of using the endpoint to populate the profiles that we have, we're actually going to use the profile service itself and populate it. So if we're making a request against the endpoint here, right, if we're making a request and the application just started, we don't expect anything to be in here. And you can start adding profiles by invoking the add endpoint. But in place of doing that, we're actually going to grab the profile service out of the registry and invoke add ourselves. So when you run this specification, we're now getting a mixture of black box testing with some interloping behavior. But the typical use case I see for this is when maybe you have some kind of data store and you want to have a clean database between test runs. So it's pretty typical that you'll either wipe out a database or table, reset row to a well-known data, and keep going again and make sure that your modifications come out. I'm not going to go over this, but there is another testing fixture. As you're working with Ratpack applications, you'll probably start working with static assets as well. And static assets are always resolved against what's called a base directory in Ratpack. So, of course, Ratpack being a good citizen that it is, it provides something that's called an ephemeral base directory. Ephemeral base directory is like a really nice utility that allows you to create temporary files that will just take care of cleaning itself up. And as expected, ephemeral base directory is also auto-closable, so you either have to close it yourself or tell Spock to clean it up for you when you're done. But there's no way I was going to write all this from memory. But basically, you're populating files with text, you're putting them somewhere, and then you're telling Ratpack that you want to use this as your base directory, and then you can start making your assertions against the static assets that are provided there. Yeah, I mean, we covered a lot today, but there's definitely more, and there's more available in the Java docs. I do want to pull up a reference to my resources. So, as I mentioned, there is a book out by Dan Woods. He's also part of the Ratpack team called Learning Ratpack. I've read it. It's a very good book. It's well put together, has great examples, and shows logical progression of how you would take a simplistic approach to a real world approach. The rest of my links in here are for Java docs, specifically for test, Groovy test, remote, and remote test. So these are everything that we covered today. And additionally, if you go to ratpack.io, please join our Slack channel. We have an active community there. It's it's quite active. If people ask questions, you'll get an answer within hours usually. Our forums are also active as well, but we like Slack for the wisdom of the crowd as well. People are starting to answer each other's questions, which is kind of cool. But yeah, that's all I have for you today. Thank you.